Smart 24, driving business.
Welcome to this week's edition of Smart Tech. I'm Andrew Barija, your host, and today we are looking at the visual impairment device, a device that was developed by students of Makerere University. And the interesting aspect about this technology is that it works with those that are totally blind. So you can imagine. So we want to find out how it really works. And where I am lately, I'm with the group of the people that are responsible, a team of 4 members, and of course with their leader. He's called Hillary. He's going to introduce himself further, definitely talking about this technology as we want to find out what really inspired them to come up with this kind of technology. And I'll confess this as a fact that this is the first kind of technology we are having in Uganda regarding visual impairment. So we want to find out how does it operate, as I'm going to first get in touch with the team leader just right with me on set. Mr. Hillary, how are you? Okay. Make more introduction about yourself. Who are you and what do you do?
My name is Dali Hillary. I'm the team leader of the CIVAS project, that's computer vision and sonification for the blind or for the visually impaired. And I'm a student here at Makerere University doing Bachelor's of Software Engineering, year 4. Yeah. So our solution is an assistive technology that employs artificial intelligence and computer vision. That means camera. Then we, using artificial intelligence, we help the totally blind person, the visually impaired, to easily find their way around obstacles, their environment, both indoors, outdoor, look for what they are looking for, find stuff, maneuver obstacles, easily get to read normal alphabets. That's in case a word is not written in Braille, they can easily get to know it, but with the use of our technology that we have implemented. Yes.
Okay, that's so interesting. So let me ask, what really inspired this idea?
So it was last year. An incident happened in Makerere. Makerere University intakes a lot of students. Among them are the students with visual impairments. Some are totally blind. So some of them are living in the university hall because they can't come from outside. It would be so hard for them. So many incidences have been happening. For example, a friend of mine was almost knocked down in the Mitchell parking lot. Yes, the driver was going out of parking. Then since he didn't have a white cane, that's the one which they use for navigating, the driver mistaken him for being a person with sight. And it was almost going down at that point until a few individuals shouted out, and they are the ones who saved him, and the driver stopped. So after that, we had to go down and with my group members go to ground and see how many cases are happening, how many of these cases are happening, which other improvements can we contribute to this society of individuals. Then hence the project. Yes, that's how it came about.
Okay. So if I may ask, tell the viewer out there, how has been your experience regarding this? Like, I know you started from somewhere. Apart from what inspired you to put up this innovation, how has been the process of putting up the team together, putting up the resources together till you finally came up with this product and the software?
We as students of software engineering, we have been studying for the past 4 years, yeah, and we have gotten to notice, of course, as you study progress, you discover the various talents of the various individuals. Yes, each person has their own attribute, something that they can contribute to the natural cause, sort of. Yes, using for over the years, we created the group. It was not initially intended for this project, but for various projects, others assignments, class assignments, like that. But then when the call came, for building this project, we had to master each of our attributes. For example, one is good at research, another is good at analysis, and is good with tech, the various technologies that can be used. So like that, from the idea, we started building, went down to ground, made some research in various organizations like Salama for the Blind, the school, then UNAB, Uganda National Association for the Blind. So we made some research. From there, we got in the various aspects of the projects that we are missing. For example, we just saw an incident where a visually impaired person was almost knocked down, right? So we had to first see which other things are happening and what best to ask the people who are involved. For example, the people themselves. Yes, we ask them the challenges they get, which organizations out there are helping them out, which technologies they are currently using. Then we understood that these technologies they were using, something lacked, right? For example, they are not smart enough. Some of the smart ones were very expensive. Then we decided we are like, okay, so we have noted this, yes. So how do we create something which is more cheaper, that can be used by an average Ugandan, yes, and also one which can mitigate the limitations of the various tools that they are using. So, hence CIVAS, yes.
Okay, that's very interesting. But when I was looking through your profile, I saw something, and the visual impairment aspect. Don't you think you're going to put other people out of business when you put this? What you're doing is totally different from what others are doing, like people who put on specs, because I believe if you can do something for the visually impaired people, apart from them being blind, there are those that actually have issues with their sight. I believe the technology also does on that. Still, however much they're not totally blind. So don't you think, how are you going to co-work with these people so that you don't cause, they may feel like, hey, these people want to take us out of business. How are you going to work hand in hand?
Right now, our major goal is to concentrate on the severe cases of visual impairment, that's the blind, totally blind. Yes, although our technology also cuts across to people, for example, those who are short-sighted, there are those who have, where the cortex is a bit rigid, so they can't really read text. But that's innovation for you. Like, you just have to move on with the flow, otherwise you work with what is available, improve on it. In the end, we are all just trying to contribute to the society and solve the challenges that we are facing. So we plan to work with existing organizations, one which can aid our project, right? Also see various stakeholders who have the same goal of helping out on society. Then we see what happens. Yeah.
Okay, maybe I was supposed to ask you this before I come to that question. How unique is it from people that are, for example, today we have specs that are sold everywhere that people are putting on. How unique is this technology from these other visual impairment traditional technologies that have been there? How unique is it?
So our solution, as I said, it caters for people who mostly, that's why it's considered the people who are totally blind, right? So you look at specs won't do anything, right? Because specs, they cater for long sight, short sight, but not the totally blind. Okay. But we are trying to help a person who's having a severe case of impairment, visual impairment, to easily find their way through society. For example, we are providing assistance. For example, in case you have kids at home, right? They are going to school, you don't want them to look for the flat iron, right? Yeah. So maybe you want to find it yourself because you don't want to really enter their program, sort of, yes. So we are trying to remove over-dependency, right? For example, we find that the visually impaired people tend to be over-dependent with others in that sometimes they need assistance, right? From an individual. But what would happen if the person to help is not around? Okay. Yes, that would lead to a disability, a visual disability, in that you can't do things without sight. So, but using our technology, we are trying to create a more advanced assistive software and machine and technology that this person can use without needing any personal assistance, for example, individual assessment from maybe cousins, family members, or the kids themselves. Yes.
Okay. Very interesting. As you can hear, this is something that is so unique in Uganda today, and I was amazed in the interview. We talked about how he was able to come up with the entire team to mobilize the resources to develop this product, and you see there is an ultimate teamwork moving on, and that's something you should take notice of as an innovator out there, that you need a team. You can't do anything alone, and this largely explains why they've been able to reach to this level they are at. We are still going on, and we are with Mr. Hillary, the team leader of this project. Mr. Hillary, we are still talking. Now, a Ugandan out there is asking themselves, how sustainable is this technology? Because there has been the aspect that majority of the innovations that are locally made within the country are despised, by the local populations, and you find that actually many go into the foreign-based innovations. Now, a Ugandan out there, they're asking themselves, how sustainable is this technology? How can I trust it, in other words? Yeah.
Yes. So let me first address the elephant in the room, right?
Yeah.
So in actual sense, there have been so many innovations. For example, I said low technology, high technology, medium technology. By low technology, I'm talking about the white cane that we see normally around. The person having a cane, the blind person having a cane which is a bit white in color, which they use to move around, right? It's good for accessibility. But then it doesn't solve the entire problem. For example, you can't know what's in front of you. You can just know that maybe there's something near me, let me take the other road, sort of. But you can't really tell. So over the years, various innovations have come about, yes, which can help you know what is around and provide more assistance to you, right? But these innovations come at a high price, right? You might find that you are going to pay over $74 for installation. That's installments for each month for the next 24 months. That's 2 years. So if we are to get that, convert that to Ugandan shillings, that's every month you're going to be spending 298,000 Ugandan shillings every month for the next 2 years. So very expensive. Then others, they have used what they call guide dogs. For example, if I'm going to the bus park, I just call my dog, maybe Abby, or whatever name they name them. Then it helps you go wherever you are going, right? But you'll find that that dog alone costs $48,000. 5 years training, it's very expensive. So our solution, we are providing a smart solution, one which uses artificial intelligence at a relatively cheap price. I'm talking about you can pay as low as 400,000 shillings. Right?
For the gadget?
Yes, for the gadget. That's the minimum it can go for, plus other customization. So, how sustainable? Well, you just have to trust us because we are trying to solve the problem. And we have credibility from, because we have been mentored by a very trustworthy person, one who we give a lot of respect, and she has been overseeing the project. That's a lecturer here at Makerere University, Dr. Mary Sabagwa, and she has been involved in so many other projects. So, well, we have been given the right mentorship. I've seen through many filters, then many reviews. So, yeah, what you can do is just trust us, because we have the right thing for you, the right product.
Okay. All right. You mentioned about the pricing, though I was actually coming to that line. Yeah, somebody would want to know, if I may ask, even the software that runs the gadget is made by you?
Yes, from the start, from scratch.
From scratch. Very impressive. Now, let's start to weigh down the pricing from the software, having the software like subscription, and also when you have a gadget. Now, I purchased the gadget. Break the pricing down for a Ugandan out there. Clearly, the different levels of the pricing, because you said 400,000, but it's like it's not it could be higher or lower than that. So, a viewer would want to know, break the pricing from the full package, because I need a full package. I need the software and the gadget.
Yeah. So we are making the software from scratch, and the hardware itself we are building it by ourselves. Yes. So right now we haven't fully made the full package What I mean by it's not yet ready to be put on the market. We are trying to take it through various iterations to make it more smaller and sustainable. For example, we wouldn't want to give it to. So okay, we're in the prototyping phase and we haven't made fully the full product, like the final product. But we are trying to we are trying to create the right solution, which is a bit cheaper, but still 400,000 Uganda shillings, that's the minimum, and maybe plus other customizations in case you want to make it any way you want, yeah. But still, when it has the same functionality as as intended, and also maybe some few customizations. Okay. Yes, and all you need is just a mobile app, right? You install a mobile app, then connect it to the hardware. Right now we're only supporting Android for now, but we are seeing that we can move it to other platforms like iOS.
So what are you supporting currently?
Right now we are supporting Android.
Android,
yes.
Only, okay.
Yes, for now. So you download the software, install it, then buy the hardware, then you just connect and let everything just work out. Yes.
Maybe lastly, tell us what have the challenges. I know you've faced challenges as you're coming up with this prototype. Is it a prototype? Can I call it a prototype? Is it right to call it a prototype?
It's a high prototype. Yes.
A high prototype. Okay. Yeah, yes. What is that you've gone through that has been challenging to develop that?
Yes. What I can start from is it's really hard to create something that is one of a kind. Yes, because there are so many barriers to overcome. For example, you find that existing hardware can't support what you are trying to create, or you are trying to create a decision. You are trying to help assist a visually impaired person in a split second. But if you look at existing computing resources, that split second, it's hard to achieve such a threshold. So we had to come up, break everything from scratch and create our own softwares and our own our own designs, our own algorithms that can really beat our goal. For example, we are applying artificial intelligence, right? And when I tell you that you are going to have an artificial intelligence module on your phone, it's practically very hard to imagine, because you find that these things are run on very expensive computers and very expensive computers. But if I tell you that we are going to put it on your phone, that means we have gone an extra mile to make sure that your phone can fully sustain this model, can fully run it. So it has been really challenging. That's one from the software perspective, trying to come up with the right software for it. Two is the hardware. For example, some of the hardware is hard to get here in Uganda, so we have had to import some, right? And importation costs, the dollar itself, foreign exchange, it was really challenging. So we had to look for the right hardware to support our product.
Yeah.
Then also the finance part. For example, we had to tap into our budget as students. Yeah.
Okay.
Yeah. Then we seek some help from the institution itself.
Okay.
Yes. They gave us some funds. We worked with that. We invested our money, and until to achieve that goal and to try to really come out with the product, because it was our dream to create something new, to change and to contribute in someone's life. Yes.
That's very interesting. And of course, that has been a brief regarding the project leader, Hilary, explaining to us how the entire experience has been in regards to achieving this project where they are right now. It's not a prototype, of course. He says it's a prototype. And of course, with the team of 4 members, we are still going to get in touch with other members, interact, and as they explain to us their experience with the product and what solution are they trying to solve. Using computer vision and sonification systems, a group of Makerere University students undertaking a Bachelor of Science in Software Engineering developed a mobile application to assist the visually impaired navigate the environment. The tool makes use of smartphone camera and sonic sensors to embed functionalities of the would-be independent devices. The devices are strategically placed and wearable, freeing the hands of the user from the load of holding the stick with the increased scope of objects that can be detected within 100 centimeters. The mobile application has collision and obstacle detection systems, vibrates and communicates to the user the obstacle ahead and gives directions to take. This enables the visually impaired to realize their due and rapid lifestyle and ensures a decrease in the bulkiness of the tool.
The device itself is a much improvement from the existing technology in the way that it is aimed at enabling much of the Ugandans to easily use it at any place in time and without incurring a lot of costs, because we observe that most of the Ugandans are having a challenge of internet access. So we had to push it forward to ensure that it can work completely offline and it can be used anywhere without that limitation. And in our future prospects, we are moving towards even eliminating the smartphone. We want to cover a biggest coverage of users without any much limitation. Like smartphone, we observe that much of the biggest population don't have access to smartphone, and we expect these people who are blind are actually having actually just receiving support from funding organizations. So we are trying to make it as much and much more accessible in the sense. So maybe the other thing is that it having the two sections of it, that is the visual movement and directions and not colliding to anything, clear direction and description, and easily locating objects of interest for use. The other component of it is not particularly to collide with any obstacle, right? To make sure that you move safely to your particular destination without ramming into any obstacle. So it depends on how you want, which budget can you pull it to. You may only need to stop at a level of just obstacle avoidance. So you just need only the obstacle avoidance, right? Not to collide into a particular obstacle, but more customization to full description, getting a much deeper description of one obstacle in terms of what it is, where it is, how you can reach to it, use it. So that is other component part of it, which may also increase on the costing.
To look at our competitors on the market, we are supposed to gain competitive advantage over them. Trying to look at the costs of their products. For example, the Ocam My Eyes, some of you know that device. It is trying to read the text. You're supposed to pay $74 per month in 24 monthly installments. Converting it into Ugandan money, the shillings, it is 296,000 per month. Try comparing that amount to the amount of our product that we are trying to come up with, only 400,000 shillings. You even have some money to save, to pay for your bills, the rent, electricity bills, you pay for your children. Meaning you're going to get this product at a cheaper price, 400,000, you still save the money to pay for other bills. Meaning, in some years to come, we're going to dominate the market, trust me.
Our solution is that we're having two separate components which work separately. We have the collision detection and the obstacle avoidance. So the collision detection is done that will help you to detect the obstacle. The collision detection will help you to bypass obstacles in case you want to find your way through, and the obstacle avoidance will help you to detect obstacles. So what do I mean by this? If I'm having if there is something like a chair in front, I will be the obstacle will have detected that there is a chair. So in case the obstacle avoidance fails to work, the other one can work in hand with this one, such that not only if one fails, then the other can do the other bit of it. And how we came up with this, we carried out some testing, and we came up with a 98%, whereby the 2% was the one whereby it had failed to detect some of the obstacles, which is a better percentage as compared to other products.
Interesting innovation right there, like you've heard the different presenters bringing out how unique this technology is. And the most interesting thing, this is a local innovation, and these are university students that's here at Makerere University. And at this very time, remember, on Smart Tech, we don't just talk about technology, but we demonstrate technology. This is the home of demonstration of technology right here on Smart Tech. At this very time, we are going to get into a short commercial break, and I'll be returning with the demonstrations. First of all, we're going to look at the hardware aspect and also demonstrate the software aspect. And of course, keep around. I'll be returning.